Hello class, let's continue with the next part of this experiment or exercise and measurement. A while ago, we were able to measure the density of the irregularly shaped solid, the p-ball, after we have determined its mass and volume as we performed the earlier part of the exercise. Now let's take a look at how do we determine the density of liquids. So in this case, we'll be using an alcohol. So by the way, water in its pure form would have a density of 1 gram per ml or 1 gram per cc or 1 kilogram per meter cube. Per cubic meter, not meter. 1,000 kilogram per cubic meter or so usually it has a density of 1 gram per ml. How about for alcohol? Which do you think is denser, alcohol or water? We'll see. Okay, so I will wipe this beaker dry, a 50 ml beaker. Again, I will weigh this beaker and we have determined kanina the average weight of this beaker based on your previous, in our computation, use the average weight of the beaker. Okay? Now I will put in 20 ml alcohol. I have to cover the alcohol right away. It's quite volatile, so to prevent excessive loss through evaporation, so you have to close that right away. And when working with alcohol, be careful not to have open flame near you because this would really catch fire. It's very flammable actually. Okay. So I'm preparing a 20 ml of that substance. Okay. So, how much is the volume of alcohol? As the reading implies, to 20 ml. Now, let's get the final mass of this beaker with 20 ml alcohol. Okay, so now it reads the 20 ml alcohol plus the beaker, it now weighs around 50.6. So our combined weight, the combined mass of the beaker, the 50 ml beaker and the 20 ml alcohol is now at 50.6. 50.6. Try to note. See for yourself. Okay? Make your observation. Okay? So our balance got into that position at 50 right here plus 0.6. It did not reach 1. So it's 51 right here, but it's on, look at the mid mark there. Okay, the marker points at 0.6. So 50.6. Okay, so that is the combined mass of the 50 ml beaker and the alcohol. So if you could notice, our 50 ml beaker was weighed previously. Okay, so the final volume 50.6. Subtract from there the initial weight of the empty beaker and you will have the weight of the alcohol. Okay? So, the weight of, or the mass of 20 ml alcohol divided by the volume, which is 20 ml, there you will know how much is the density. Do your computation. Okay? Then, after this, after you have computed for the density of alcohol, try to do your own research. You can use the net, the internet, and look for the theoretical volume, density value for ethyl alcohol. And compare that with your computation. If you could notice, there will be a little discrepancy. When I say discrepancy, it would not exactly match, but the difference would be if you will compare your computed from the theoretical value which you can gather from research would not be too far from each other. The difference would be quite small so that we can say that it might be attributed to some inherent error from the device that we are using, but it should not be too far from the theoretical value. So the theoretical value is the one that you can get from your research, and the actual or computed value is the one that you can get from this experiment. So that ends this part of the experiment. We will proceed to the last part of experiment or activity number 1 on temperature. So I will get that in a little while.